of this, because Japan is not so big country in terms of like land area, so they cannot put like anywhere. They have to manage it, either incinerate, or they don't have like big landfill. So initially it was really difficult to how to deal with that large amount of waste, and how to make like separate the different types of waste, like wood waste or like metal waste or some other waste. So but gradually they did it. And then tsunami deposit, like sedimentation. So after tsunami came, the and stayed around like half days or something, so a lot of sedimentation happened, like in some places where we visited, like almost 20 centimeter, 25 centimeter. Sorry. Tsunami deposited, sedimentation happened, and that caused the totally different story of the, especially for the agricultural field. And many of them contain salt and toxic chemicals. And do you know where is this toxic chemicals came from? Like hundreds years ago, when the environmental protection is not so good, many sorry, many industrial waste goes to the sea, and it gradually settle under the seabed. And when the tsunami wave comes, it just mix together with all the settled sediment and then come to the shore and gradually settle. So it has lot of toxic chemicals. Like normally Japan don't think about the arsenic in the soil, but after the tsunami they found lot of areas are affected by higher concentration of arsenic. And of course the saline water of the is very much dangerous. So saline water comes and make the soil saline and unusable for the agriculture. And also soil and groundwater contamination due to the damage of storage facilities. For example, like a lot of refrigerators, lot of freezers, they just washed away, and after collecting those and put in the some temporary landfill site, some fluoride or fluorine, these type of things are just leached and go to the groundwater. So that was another caused some problem. And of course, the nuclear accident which was happened in Fukushima, so that causes a lot of problems in terms of geo-environmental point of view, like high radiation surroundings the nuclear power plant, and nobody can go enter there. So still Japan is fighting to how to protect that one and how to get rid of that accident. And of course sanitary problems and environmental issues due to the, in many places ground subsidence happen. So here is some view of the separation of the waste after the tsunami. So a lot of concrete waste is dumped and separated, and the damaged cars and like woods and scraps of iron, they put it. And also they made some places for like home appliances like refrigerators or freezers or TV or something like that. And yeah, but they put it first temporarily, and after that they gradually manage it, because after the tsunami it was the greatest challenge to how to deal with the debris or waste the first time, because it was really not so easy. I did some volunteer job there after the tsunami, so it was really hard job. Like you don't have any restaurants, entire city destroyed, so you have to prepare your food by yourself, and you have to carry your water by yourself, and all the day you have to work in this like huge amount of waste and everything. So here This is some examples like how far the tsunami water entered. The red color is the place up to where the tsunami water entered. So from the shoreline, the maximum reaches like 10 kilometer, like 6 miles or something. So it's really, really far away from the shoreline, and due to that, lot of agricultural area or agricultural land became contaminated. So we tried our new technology, we call it bioremediation. So using some specific bacteria, we tried to clean that agricultural land, because the traditional way to clean the high saline soil is very difficult, especially when you don't have enough source of fresh water, and how to drain away the fresh water, clean after the clean. So we tried new technology with bioremediation, and we chose the Rikuzen Takata city. It is in Iwate prefecture, because this is mostly affected by the tsunami, and this is the view of that entire city. Yeah, another view of that. So not only the houses, but also the agriculture field washed away. And yeah, in that city there was very famous, like 70,000 pine trees near the sea beach, and that was built for the protection of tsunami. But after that tsunami, all the trees are washed away. Miraculously, only one pine tree survived, that one. So the people of that area, they thought this is like symbol of their hope to fight back from the tsunami. And this photo is also taken by me, like this is one like government housing for the people in Japan. So the tsunami water reaches up to the 4th floor, sometimes 5th floor also. So in that city, like Rikuzen Takata, you can understand how much the height of the tsunami water. So we did some tests at first. So those who are not familiar with the salinity of soil, like those soil which have high salinity, like we measure it by electrical conductivity. If it is more than 0.3 millisiemens to 0.7 millisiemens per centimeter, then no plants can survive, like poor or little crop production. So especially for the case of rice production or corn production, they cannot survive in the sandy soil. And this problem is not only caused by the tsunami. Salinity problem or saline soil problem is happening all over the world, especially due to the desertification, a lot of irrigation. Even in California, in the Central Valley, which is very famous for agriculture, but they are now facing this high salinity problem. And in Australia, in Asia, in Africa, of course, a lot of areas are every day become unsuitable to cultivate due to the high salinity. So this is not only the problem of tsunami, and due to the global warming, climate change and sea level rises, new area is affected by the high saline soil, because seawater intrusion or seawater approaching to the residential areas or agricultural areas make the scenery more serious or more vulnerable. So what we did, so like this is one corn field, and you can see that corn was not grown well after the tsunami. They tried, washed, and their traditional method. So the farmers lost not only their crops but also the land they used to harvest due to the tsunami. So we tried to do some like field test. First we collect the samples from there, and this farmer from Japan, he is doing some organic farming, but his compost pile is also affected by the tsunami. So we tried to figure out whether they can use it by using bacteria or not. And after the soil test, we found most of the areas the uh, safe limit for the electrical conductivity or salinity is much higher than the standard level. So what we did, we make some homemade compost by using rice bran, oil cake, fish bones and mixing with water. And this time we used one specific bacteria, we call it halobacteria. This is salt tolerant bacteria. And after mixing, we preparing this compost, and then we used on the, like, after during the cultivation we put it in the surface of the agricultural field, and then the bacteria, due to the bacterial activity, the salinity will be removed, and we tested it in the lab. So this is like control, and this is mixing with compost. So plants survive when we're mixing with compost or grown. So we did it in the cornfield in Rikuzen Takata and on the another sunflower field, and it worked very well. Here is what is the mechanism behind this, that like when the bacteria activity is happened, they just make some absorbing sodium, and the chloride portion is become like biovolatile. So due to the metabolic action of the bacteria, it becomes a gas. So gradually it cleans the salinity. Then in the lab, we try to figure out whether we can do it little bit faster. So we use some collective microorganisms. So not only first trial we did only single bacteria, halobacteria, but this time we tried with some like homegrown collective microorganisms. One we call it like CM1 and CM2. In CM2 we particularly use some photosynthetic bacteria. So in photosynthetic bacteria, they are very much common in the rice field and everywhere. So we tried with that one, and they are very good at salt tolerance as well. And this is some of the results for that. Like when CM2 was used, like the reduction rate was like 66% after 5 weeks. That was the maximum effective. And then pH value is also in the good range, because for geoenvironmental properties pH is also very important. Then we try to figure out like whether this like CM2 bacteria, can we make it little bit faster. So we thought like if we make them more suitable place to live this bacteria, then it could happen a little bit faster. So we use some foamed waste glass. This is nothing but like recycled waste glass, and it is widely used in Japan as like geotechnical geomaterials. So we tried to put this foamed waste glass in 2 layers, like in the middle and in the lower level, and then use the CM2 bacteria culture. And we found that after this mixing in layer, the reduction rate is also become faster, and pH also in good range. Then what we did, not in layer, we tried to mixing together to make effect of the whole things, and we found that if we mix together, then even in the lower portion the EC becomes in very good condition, and within the range almost good condition. So the foam waste glass has some pore space inside, and bacteria like to stay and grow there to make more effective bioremediation. Yeah, that is the same mechanism happened what we did in the field first. So biovolatilization and some chelating. So this is the conclusion. So we have found that electrical conductivity reduced through the bioremediation, and CM2 is more effective than CM1.